In the vast expanse of space, something extraordinary connects the cosmos. Massive bridges of superheated plasma stretching between galaxies, hidden from our view until now. For decades, astronomers suspected these cosmic connections existed, but they remained invisible to our instruments, too faint and diffuse to detect with traditional telescopes. The search for these elusive structures began in the 1980s when computer simulations first predicted their existence, suggesting they formed an intricate cosmic web throughout the universe. It took the development of incredibly sensitive radio telescopes and revolutionary observation techniques to finally catch a glimpse of these cosmic highways. The breakthrough came when scientists realized they could detect these structures by observing the extremely faint radio emissions produced by electrons moving through magnetic fields within the plasma. What they found was astonishing. A network of plasma filaments, each spanning millions of light years, connecting clusters of galaxies like a cosmic spider web. These structures had been literally hiding in plain sight, too dim for our instruments to detect, despite being some of the largest structures in the known universe. The filaments consist of incredibly hot plasma, heated to millions of degrees, yet so diffuse that they remained invisible until we developed the right tools to see them. This discovery has opened an entirely new chapter in our understanding of the universe, revealing how galaxies are connected and interact across the cosmic void. As our technology continues to improve, we are now mapping these cosmic bridges in unprecedented detail, revealing their crucial role in the evolution and structure of our universe. Let's journey inside these remarkable cosmic structures to understand what makes them tick and how they've become the largest known structures in our universe. At their core, these filaments are made of plasma, a superheated state of matter where electrons have been stripped from their atoms, creating a soup of charged particles that respond to magnetic fields. The temperature within these plasma filaments is almost beyond comprehension, reaching up to 40 million degrees Celsius. That's hotter than the core of many stars. The plasma isn't uniform. It contains regions of varying temperature and density, with magnetic fields acting like cosmic guardrails, keeping the structure coherent across vast distances. The scale of these structures is mind-boggling. A single filament can stretch for hundreds of millions of light years. If our solar system were the size of a grain of sand, these filaments would still be longer than the Mississippi River. The material within these filaments isn't exotic. It's made of the same elements we find everywhere else in the universe, primarily hydrogen and helium, just in an extremely energetic state. These filaments act like cosmic highways, with matter flowing along their length at incredible speeds, feeding into the galaxy clusters at their endpoints. When we map these filaments across the observable universe, they form an intricate web, the largest known structure in existence, making individual galaxy clusters look tiny in comparison. The magnetic fields within these filaments perform a crucial role, capturing and channeling matter that would otherwise disperse into the void of space. These aren't static structures. They're dynamic, growing and evolving over billions of years as they continue to transport matter and energy across the cosmos. Within each filament, plasma churns and swirls in complex patterns, creating turbulent flows that can span thousands of light years, yet maintain their structure through the immense gravitational and magnetic forces at play. For years, cosmologists faced a perplexing problem. When they added up all the visible matter in the universe, enormous amounts were mysteriously missing. Our calculations showed that ordinary matter, the stuff that makes up stars, planets, and everything we can see, should make up about 5% of the universe. But when we looked out into space, we could only find about half of it. Scientists knew this missing matter had to be out there somewhere. It wasn't exotic dark matter or dark energy. This was ordinary matter, just hidden from our view. Traditional telescopes showed us seemingly empty space between galaxies. But new observations of the plasma filaments revealed something extraordinary. This void wasn't empty at all. The missing matter was hiding in plain sight, spread so thinly through these cosmic filaments that it was virtually invisible to our instruments. These threads contain vast amounts of hydrogen and helium, exactly matching the composition we were looking for. By detecting and measuring these plasma filaments, we finally found the missing piece of the cosmic puzzle. The matter wasn't missing. It was just diffused across the largest structures in the universe. Using a combination of X-ray observations and radio telescopes, scientists confirmed that these filaments contained enough matter to account for nearly all of the universe's missing ordinary matter. Just like that, decades of searching came to an end. The matter wasn't lost in some exotic form or hiding in unknown dimensions. It was stretched across the cosmic web, binding our universe together. These filaments don't just store this matter, they transport it. Like cosmic rivers, they flow with the materials needed to form new stars and fuel existing galaxies. This discovery has transformed our understanding of the universe. By finding this missing matter, we've confirmed our theories about how much ordinary matter exists in the cosmos and unveiled the vast network that connects it all together. And if you're fascinated by these cosmic discoveries as much as we are, make sure to subscribe to our channel. We're constantly exploring new mysteries of the universe, and there's so much more to uncover together. Now, let's look at how these cosmic highways shape the evolution of galaxies themselves. We used to think galaxies were isolated islands in space, but now we know they're connected by vast networks of plasma that act as cosmic supply lines, continuously feeding their growth and evolution. Even today, billions of years after their formation, galaxies continue to grow. These plasma highways deliver a steady stream of material, allowing galaxies to form new stars long after their initial creation. Like rivers on Earth carrying nutrients across continents, these plasma filaments transport the essential ingredients for galactic life: hydrogen and helium gas, along with heavier elements forged in ancient stars. The process works through a delicate interplay of gravity and magnetism. Matter flows along magnetic field lines within the filaments, eventually collecting at intersection points where galaxies tend to form and grow. When this material reaches a galaxy, it doesn't immediately form stars. Instead, it first feeds into massive gas clouds that slowly cool and condense, eventually creating the perfect conditions for new star formation. The flow of matter isn't uniform. Sometimes it moves in vast streams, other times in smaller droplets, creating complex traffic patterns that can trigger bursts of star formation when large amounts arrive simultaneously. Galaxies positioned at the intersections of multiple filaments tend to grow into the largest and most massive structures, receiving material from multiple cosmic highways at once. This network explains one of the biggest mysteries in astronomy: how galaxies have maintained their star formation rates for billions of years without running out of fuel. By comparing ancient and modern galaxies, we can see how these cosmic supply lines have shaped galactic evolution, determining which galaxies thrive and which stagnate based on their position within the cosmic web. Understanding these plasma highways allows us to predict the future of galaxies, including our own Milky Way, as we better grasp how they receive the materials needed for continued growth. These cosmic threads will guide the destiny of galaxies for billions of years to come, orchestrating a cosmic dance of growth, merger, and evolution that will continue long after we're gone. Perhaps the most astounding discovery about these cosmic webs is how they mirror patterns we see much closer to home, specifically in our own brains. When scientists first mapped the cosmic web in detail, they were struck by an uncanny resemblance. The network of plasma filaments connecting galaxies looked remarkably similar to networks of neurons connecting regions of the brain. The similarities are more than superficial. Both networks show remarkably similar connection patterns, with nodes, whether galaxy clusters or neural centers, linked by long filamentary structures that transport essential materials. Despite their vastly different sizes, one measured in millions of light-years, the other in micrometers, these networks follow surprisingly similar organizational principles. This pattern, known as branching fractals, appears throughout nature. We see it in tree branches, river systems, lightning bolts, and now, in the largest structure known to exist. These recurring patterns suggest there might be fundamental principles of organization that nature follows, from the smallest to the largest scales. Both networks are optimized for efficient transport. In our brains, neurons carry electrical signals and chemical compounds. In space, plasma filaments carry matter and energy between galaxies. The mathematical patterns governing how these networks branch and intersect are remarkably similar, suggesting that nature may have a preferred way of solving the problem of network distribution. While these similarities don't suggest cosmic consciousness, they do hint at underlying mathematical principles that govern how complex systems organize themselves across vastly different scales. Both networks also grow and evolve in similar ways, starting from simple connections that gradually become more complex as they respond to the flow of material through their structures. These similarities remind us that, despite the vast differences in scale across our universe, nature often finds similar solutions to similar problems. As we conclude our journey from the microscopic to the cosmic, we're left with a profound appreciation for the patterns that connect everything in our universe. If you've enjoyed exploring these cosmic mysteries with us, don't forget to like and subscribe for more fascinating journeys through space and time. Until next time, keep looking up and remember, we're all connected by the same cosmic patterns that shape our universe.